This lesson is primarily for grade 10 science in Ontario, SNC2D, and we're just looking at the nomenclature and basic chemistry structure. This may be a review for some of you, or it may be totally new. And so we're going to start with some early terminology. So we need to know what an atom is. We need to know what an ion is. We need to understand the concept of a molecule and what an compound is. Okay, they're all related in some way, but we need to be able to look at them and talk to them in different structures. So an atom, as you learned in grade 9, is basically a simple structure that is made up of protons and neutrons in the nucleus of the atom, and then going around it are the electrons. Okay, and an atom is a neutral charge, which means the protons equal the number of electrons. And I'm not going to go through it, but you know the concept of atomic mass versus atomic number. So if you're trying to figure out the number of protons, always look at atomic number. Okay? An ion is more of what we would call the stable version. Okay? It's the stable version of an atom. Basically, what you've done to make it stable is you have filled the outer shell with electrons. That is, if we're talking in terms of a Bohr-Rutherford diagram. So the outer shell or the outer orbital is filled. That creates the dynamic that it would be like a noble gas. And so when you're looking at that, you have to remember, well, what would make it easier? So if we looked at an example of sodium, okay, you want to make sure the sodium atom, look it up in a periodic table. Where do you find sodium? You look at, it's on the far left, right, because it's an alkali metal. It's element number 11, which means it has 11 protons and 11 electrons. So if we did a really quick look at it, there's 11 protons in the middle. And then in the first shell, remember, we can have 2 electrons. And then the next outer shell, you have 8 electrons. And that accounts for 10 so far. And then the next shell, we only have 1 electron left. And there we go. Okay, 1 electron obviously isn't full because the second shell would, or the third shell is able to have 8 electrons. So you're either going to take away an electron or you're going to insert 7 electrons. Well, they're pretty easy going, so they're going to take away an electron, which would give us 11 protons and 10 electrons. And if you look at it in terms of dance partners, the positives, 4, 5, 6, 7, 8, 9, 10, 11. There's 11, and you want a dance partner. Well, in a neutral atom, the positives equal the negatives, but here we have 1, 2, this isn't working, 3, 4, 5, 6, 7, 8, 9, 10, and notice there is 1 missing. So we now have an overall charge of +1. So the ion is the charged version of an atom. So the sodium ion is not just sodium, it's sodium 1+. It's got a charge of +1 or 1+. Okay, so when you start doing ions, you have to think about the displacement of the electrons, whether you're adding them or taking them away, and what happens to them. Okay, so that's the ion. You've done that already. Now a molecule, oh, I left one out. I forgot element too. Oops. A molecule is just more than 1 atom together. Okay, or more than 1 ion together. A compound is greater than 1 type of element bonded together. Okay? And an element is just one type of atom. Sorry, I'm getting it squished around there. Okay? So atom, ion, molecule, compound, element. So when we look at it, if I look at magnesium, for instance, magnesium by itself is just Mg. It's an element. You've talked about water before. Water is H2O. Well, H2O means there's 2 hydrogen atoms and 1 oxygen atom together. And since there's more than 1 atom in that formula, that's a molecule. But because there's more than 1 type of atom, it is also a compound. Okay? Magnesium by itself is an element, but it's also not a compound. It's an element, and it's not a molecule, it's just an atom. Okay? So that's the difference. Now I'm going to throw one at you. Oxygen gas. Oxygen is O2. Well, what is it? It's an element because it is one type of atom, but there's more than one of them, so it's also a molecule. So don't forget that molecules can be that way as well. So that's an element and a molecule, that's a molecule and a compound, and that's an element and an atom. So now we're going to talk about how to form these things and start looking at it. And the way I look at it is you have to look at it from a perspective of a flowchart. And so I do a strange way of doing it. Some teachers do it one way, other people do it other ways, other teachers do it different. So if this works for you, hopefully it works. We can talk about it and figure it out. All right, let's start on a new slide. And when we start looking at things, we're going to take it as a flowchart. And the flowchart, we're going to start looking at it sort of dichotomously. You're going to look at either the name or the element chemical formula. So you're looking at the formula or the name, and you're going to look at it. Is it elemental? Is it an element? Or is it a compound? Okay, so that's what you're going to start with. Element or compound. If it's an element, so A, we're going to look at an element. You're going to look at it, is it Hofbrinkel? Or is it not? Okay? So when you look at the element, if it's Hofbrinkel or not, those are your two options. So it's either Hofbrinkel or not. What do you mean by Hofbrinkel, Mr. Ruddy? Well, Hofbrinkel means any of the elements, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine, if they're only by themselves, they become a diatomic molecule. Okay? And the diatomic molecule means anytime they're written by themselves, so if you say hydrogen gas, it's a diatomic molecule, di meaning 2. So H2, or oxygen gas, is O2. Nitrogen gas, N2. So whenever you see them, if they're written only by themselves, this is key, this is vital, vital, vital. If they're written only by themselves, they become diatomic molecules. And you keep the same name. So it's hydrogen gas. Fluorine, bromine, iodine, nitrogen, chlorine. If it's not, then it's going to be written just as its element. So example, magnesium, iron, silicon. Those are written only as themselves. And their names just stay the same. Okay? So Hofbrinkel, diatomic. Anything else? Not. Just by itself. So when you're writing out the formulas, Hofbrinkel will be diatomic. Anything else? Not. That is key. That's your elemental stuff. Okay, if it's an element, is it Hofbrinkel or not? Just have to remember. Now, let's take a look at the compounds. And to do the compounds, we're going to go to the next slide. Okay, so we're getting to a compound. Now you have to be able to know what you're looking at on a periodic table. You should always have a periodic table with you so you can look at it. Is the compound made up of two elements from the periodic table? Okay? Is it made up of two elements from the periodic table? All right, so if it's two elements, or is it more than two elements? Okay, so if it's more than two elements, we're going to do something that's called, we'll come to this after, but what we call that are the polyatomic ions. That's what we're dealing with. And polyatomic ions have their own rules. Okay, so we're going to follow polyatomic ions later. Let's go to the two element stage. Okay, so as two elements, you're going to split it off. And is it a metal plus a non-metal? Remember, metals are on the left and the non-metals are on the right, and there's that staircase that runs down. So the metals are like the Harry Potters of the world. They live underneath the staircase. Okay, so if it's a metal and a non-metal, you're going to follow ionic rules. Okay, just like if there's more than two elements, you follow the polyatomic ion rules. If it's a metal and a non-metal, you follow ionic rules. But if it is two non-metals, you're going to follow the covalent, or as they sometimes call it, the molecular rules. And the key is you can follow all these rules and be able to do and answer anything and everything that way. Okay, let's start with some ionic rules, because the ionic rules, there's actually another set. So we're going to take this, and the ionic rules you're going to either single valence, rules, or multivalent rules. Okay, so let's just go through ionic rules, and then I'll start a new video on the other ones. So let's do ionic rules. Single valence. Okay, so let's go back and remember. You start looking at it. Is it a elemental or is it a compound? Oh, it's a compound. Okay, it's made up of two or more than two. It's made up of two. It's a metal and a nonmetal. So these are your ionic rules. Okay, and so when you name your compounds here, naming using ionic rules with a single valence is easy. The metal goes first, is the first one. Then the non-metal ion is second. So that's the first one when you name it. Okay? The second part of that is the metal name stays the same. The metal name is the same. But the non-metal, well, the non-metal ion ends with I, D, E. Okay, so the nonmetal in an ionic compound is an IDE. Okay, so here's an example. An example I'm looking at, I've given you the chemical formula of NaCl. Na is sodium, Cl is chlorine on the periodic table. Sodium is the metal, chlorine is the nonmetal. They've joined together in an ionic compound, so they've actually exchanged electrons. Okay, the sodium gave away an electron and the chlorine actually accepted it to become a chloride ion. So the name of this is now sodium chloride. Note, sodium is the name of the metal, chloride is the nonmetal ion. So the metal ion stays the same as the name, and the chloride ion becomes the ide. Okay, here's another example. CaO. Well, CaO is calcium oxide. So when you're naming it, it's very simple. The metal name goes first to the ion, and then the nonmetal ion name goes second. As long as this is a single valence. Remember, single valence means there's only one charge possible. Now let's form the compounds. Okay, let's form the compounds. Okay? And remember, we're talking single valence here. Make sure you have a periodic table of ions in front of you because you want to be able to look at these things, okay? So let's look at lithium and fluoride. Okay, so find lithium, left-hand corner. If you look at the ion, lithium has a charge of +1. Fluoride has a charge of -1. Okay, so because lithium has a charge of +1, it means it gave away 1 electron. Okay, fluoride, on the other hand, in order for it to be happy and have a full outer shell, it accepted the electron. And so for this one, it's really easy. The electron from lithium that got away simply went and joined here, and since lithium and fluoride you have equal, you want pluses to equal the minuses. That's the goal of the game here. Lithium fluoride becomes LiF. Simple. 1 lithium to 1 fluoride. Not that scary, hopefully. Okay? So let's try something a little more challenging. Let's look at calcium chloride. Okay, and when you're looking calcium, you look for it. Calcium, oh, it's on the second column. Ca, it has a charge of 2+, which means what? It means it's going to give away 2 electrons. Chloride, on the other hand, has a charge of -1, or 1-. Okay, so calcium is +2, chloride is -1. Giving away 2, accepting 1. The goal, again, the pluses are to equal the minuses. That's the goal. So if I went like this and went CaCl, that's not equal, because 2+ and 1- does not equal. The pluses don't equal the minus. But if I add a second chloride ion, what have I done here? I've now got a +2 here, a -1, and a -1, which is -2. So +2 equals -2. Now I can see it and go, oh, well, my chemical formula must be 1 calcium to 2 chlorides. Okay, we're going to end with one more just to see how well you're understanding this. So if I said aluminum or aluminium oxide, depending on where you're listening from, aluminum oxide. So if we start looking for aluminum, it's right below boron, okay? And aluminum, the ion, has a charge of 3+. Oxide is the oxygen ion, which is O2-. Now, an easy way, the way I always look at it, is I just start adding things one side to the other. So if I have 3 being given away, that means I have to get 3. So I only have 2 on this side, which means I have to add another 2 minus. But now I've got 4 minus, correct? Which means, now I only have 3 over here, so I better add another one. So I'm going to add another one over here to get 3 plus. So 3 plus and 3 plus is 6. Oh wait, there's only 4. Now I'm going to go O2 minus, and now I've got 6 minus over here. Does everybody see that? Okay, so 6 minus on this side. And then over here I've got 6 plus, which is really important because, as I said, pluses are to equal the minuses. Well, then when we write it out, how many aluminums have I written? Well, I've got 2 aluminums, and how many oxides? 3. Please note, very important. When you write elements, it's a capital followed by a small letter if it's 2 letters. If it's only 1, like O, it's capitalized, always. And if you're writing a chemical formula, it's very important that these numbers are subscripted. If you don't do it correctly, you're not following proper protocol, and that is not correct. Okay, so please, if you're typing them out, make sure you learn how to use the subscripting. Hopefully that makes some sense, and the next lesson we will look at multivalent ions, ionic compounds, and then we will do polyatomic ion compounds and covalent compounds.